Okay, so today what we're going to be learning about is another way that we can solve a system of equations without having to graph the equations. It's called the substitution method. Okay, so today we're going to be learning about how to solve systems by using the substitution method. Okay, the substitution method is a good method to use if you don't want to graph and at least one of the equations is solved for either x or y. Okay, so when do you use this method? Okay, 1, if you don't want to graph. And 2, you would typically use this method if at least one equation is solved for either x or y. Okay, so these are the situations where you would use this method. Now, I'm going to show you guys this method, and some of you guys may really like this method. You may like it better than graphing. Okay? Some of you guys will see this method and you won't really care for it, and you'll prefer graphing over this. I don't really care which method you use, like on a test or a quiz. It doesn't matter to me how you find the answer, whether you do it by graphing or whether you do it by substitution, which is more of an algebraic method. Okay, either method will come up with the same answer, and it will be correct. Okay, so this is just another option for you guys to use. All right. Okay, so let's go ahead and let's take a look at our first example. Okay, so when I'm looking at these two equations, I notice that they're both solved for y. They're actually both written in slope-intercept form, right? So if I were to graph these, it wouldn't be so bad to graph them, right? Because they're already both in slope-intercept form. I know the y-intercept, I know the slope of each of them, right? But maybe, I don't know, I don't feel like drawing a graph, or maybe this y-intercept, it's pretty large, it's -12, so maybe I don't feel like drawing a graph that large. So I can use this method instead, which is where I don't have to graph, I can solve algebraically, okay? So what you're doing in the substitution method is you're taking one of the equations, you're going to take the one that's set equal to y, or set equal to x, in this case they're both set equal to y, and you're going to plug it into the other one, okay? Now, it doesn't matter in this one since they're both solved for y what I do. But what I'm going to do is I'm going to take this whole thing here, this whole part, and I'm going to plug it into the other equation in the place of y. Because isn't this whole thing equal to y? So then I can replace this y with this because this is the same thing as y. Okay? So here's what my new equation is going to look like. I'm putting this in the spot for y, so I'm going to get 5x, -5x, minus 12 equals the rest of this. Okay, now the whole point of substitution, what you're trying to do is you're trying to get one equation with only one variable. Okay, so now look at this equation I have now. Does it have only one variable? Yeah, it only has x, right? And so now that it only has x, what I can do is I can solve this for x. So let's go ahead and draw our line down the middle of our equal sign, and let's start solving for x. So one of the things I need to do is get all the variables to one side. So would you guys like me to move the 5 over here, or you want me to move the 3 over there? 3? Okay. So let's go ahead and subtract 3x from both sides. Okay, and I'm going to get negative 8x minus 12 equals negative 4. Don't forget this was a negative when you bring it down. Okay, so now I'm going to move the 12 over. So let's add 12 to both sides. Okay, what's negative 4 plus 12? Positive 8, right? Okay, so now how do I continue solving this? Yeah, divide by negative 8. Good. So I'm going to go ahead and divide by negative 8 on both sides. And what is 8 divided by negative 8? What kind of 1? Negative. Yeah, negative 1. Okay. So now what I've done is I've found the x value. Okay, the x value is negative 1. Now remember, when I'm solving a system, what I'm trying to find is the point where they cross. So remember, when I write that point down, I write an x value and a y value, right? Like for example, 2, 7 or 3, negative 1, whatever. It's an ordered pair, okay? So I have the first part of the ordered pair, negative 1. I need to find the second part of the ordered pair. So how do I do that? Well, if I know this x, could I plug this x into either one of these and find the y value now? Yeah, okay. So what I'm going to do is after I've solved for this variable here, which is x, I'm going to take this number that I get and I'm going to plug it back in to the first equation. Okay, so here's what I'm going to get when I do that. I'm going to get y equals negative 5 times, what am I plugging in for x? Negative 1 minus 12. Okay, and I'm just going to work this out. Okay, so I get y equals, what's negative 5 times negative 1? Positive 5 minus 12. Okay, well, what is positive 5 minus 12? Negative 7, right? Okay, so now that I have my x and now that I have my y, can I now write the ordered pair that is the solution? So, which one goes first in the solution, x or y? X. This is the same ordered pair I would get if I were to just put both of these on the graph and graph them. Okay, now, how many of you guys prefer graphing over this method? Like you think graphing is easier? How many of you guys like this method? Okay, all right. So like I said, I don't really care which method you use. I'm just trying to show you guys another way, like a different option, okay? All right, we're going to practice another one. Okay, so let's take a look at this second example. Okay, is there anyone who needs more time catching up through here? Okay, all right, and remember, this was your final answer. Okay, all right. Okay, let's take a look at this next one. Okay, so those are your two equations right there. Okay, so we're going to look for at least one of these to be solved for x or y. Is at least one of them solved for x or y? Which one? The top or the bottom? The bottom solve for x, like x equals is by itself or y equals is by itself. No, which one solve for either x or y? The top, this one. It has y equals. The y is by itself, right? Okay, so if this is the one that solved for y, I'm going to take this and I'm going to plug it in to the spot for y in the other equation. So I'm going to plug this in right here. Okay? So now what I'm going to do is I'm going to rewrite this second equation using this whole thing in the spot for y. So here's what it's going to look like. Negative 5x plus 2 times this whole thing. Well, if I want to multiply 2 times this whole thing, I need to put it in parentheses because I'm multiplying it by everything here. So negative 5x plus 13 goes in parentheses. Okay, and then equals negative 19. Does that make sense how I got that? I just put this whole thing in the spot for y. Okay? All right, so now let's go ahead and solve this equation. Okay? So in order to solve this one, I need to do some simplifying on this side. What property do I have here that I need to apply? Okay, so let's distribute. This is a positive 2. I'm going to distribute it to both of those parts. Okay? So we get negative 5x minus 10x plus 26 equals negative 19. All right, now, your x's are already both on the same side of the equation. So let's keep them here. Let's just move this one over, and then we can combine these. Does that make sense? Okay, so we're going to go ahead and subtract 26 from both sides. What's negative 19 minus 26? Negative 45. Okay. Now, in this same step, is it okay with you guys if I combine these? What's negative 5x and negative 10x? Negative 15x. Okay. And next, what do I get when I solve for x finally? My last step. Divide by negative 15. Okay, so I get x equals what? Positive 3. Okay, so what am I going to do with this positive 3? Where do I plug it in? Back into the beginning, right? Does that make sense? So I'm going to take this positive 3, because right now I only have half of the solution. I need to plug this back in to the x spot right there because this is equal to x. Okay? So let's go ahead and plug that in. Y equals negative 5 times 3 plus 13. So now I just need to work this out so I can figure out what y is. So what's negative 5 times 3? Negative 15. It's negative 15 plus 13. Negative 2. Okay, so what is your final answer? 3 comma negative 2. Okay. All right, does that make sense how we did that one? All right. Okay, I want to do one more example with you guys. Do you need more time getting caught up here? Yeah or no? No? Can I turn the page? Okay. All right. So let's take a look at this one. Instead of having something solve for y in this one, what does it solve for? Solve for x, right? So the only difference here when it's solved for x is I have to take this whole thing, and instead of plugging it into the spot for y, I can't plug it into y because it's not equal to y. It's equal to what? X. So it has to go into the spot for x in the other equation. Does that make sense? Okay, so I'm going to rewrite this second equation using this whole thing in the spot for x. So I'm going to rewrite 2 times, this whole thing is going in the spot for x. 2y plus 4 minus 4y equals 8. Is everyone following how I got there? Yes or no? Yeah? Okay. So now from there, I'm going to go ahead and solve this equation since now it only has one variable. Okay? So let's go ahead and apply distributive property. So we get 4y plus 8 minus 4y equals 8. Okay, I noticed that both of the variables are here already. I'm going to leave them on this side. I'm just going to move the 8 over here. Okay, so I'm going to subtract 8 from both sides. Alright, so on this side I'm left with 4y minus 4y equals, what's 8 minus 8? 0. Okay. Alright, next, what's 4y minus 4y? What's 4 minus 4? 0, right? So I have 0 y's, right? So what's 0 times y? 0, nothing, right? So I have 0 equals 0. Now this is kind of weird, right? In the other two problems, I always got like y equals something or x equals something, right? But in this problem, my variable completely eliminated itself, and I have 0 equals 0. So here's what that means. That means that I cannot find the y-coordinate of where they cross. So this means that they don't cross, or that they overlap. It's one or the other, right? It's either no solution or it's an infinite solutions, okay? So how do I know which one it is? If it's a no solution, I would end up with like 0 equals 5. I would end up with a not true statement. That would mean no solution, okay? But in this case, is this a true statement? Does 0 equal 0? Yes. So if it's a true statement when my variable eliminates, that means that they are the same line, they're overlapping. So what kind of solution is that when they overlap? Infinite solutions. So this one, I can actually stop here, okay, and I can just write down that I have infinite solutions, okay? So that's my answer there. Now, if you get this same situation, but you get like 0 equals any other number besides 0, like 0 equals 1, or 0 equals negative 10, or 0 equals 5, that means no solution, because that's not true. Does that make sense? Okay? All right. Are there questions on this one? Okay. I want you guys right now to take a picture of your homework. It will also be up on School Loop. Okay. Hold on, let me find it. Okay, and this is homework for tonight. So you guys need to complete odds. Odds only.